In this example, we're presented with two independent random variables, x and y. X and y both take the values 1 and 2. The probability that x is equal to 1 is equal to 0.05, and the probability that y is equal to 1 is also equal to 0.05. And we're asked to calculate the probability that either x is equal to 1 or y is equal to 1, or both. So in other words, the probability of the union of x being equal to 1 or y being equal to 1. So let's remind ourselves about how we do this. To help us, I've begun by writing down the probability distribution function of x and y. X can take the value 1 or 2, and the probability that x is equal to 1 is equal to 0.05, and similarly y can take the value 1 or 2, and the probability that y is equal to 1 is also equal to 0.05. We're asked to try and find the probability that x is equal to 1 or y is equal to 1, or both, so the union of the two events. We're also told that x and y are independent, and that's going to help us to calculate this probability. Now, I'm not going to calculate the entire joint distribution, but we can represent the joint distribution using a Venn diagram. So we can represent the outcome where x is equal to 1 in our blue circle. We can represent the outcome where y is equal to 1 in our red circle, and then we've got an intersection between the two where both x is equal to 1 and y is equal to 1. Now, if we wanted to find the probability of x being equal to 1 or y being equal to 1, we're going to add together those two probabilities, but we'll end up counting that intersection twice, because the intersection appears in both the area where x is equal to 1 and the area where y is equal to 1. So in order to find the probability that x is equal to 1 or y is equal to 1, we add up the probability that x is equal to 1 plus the probability that y is equal to 1, and then subtract the probability that both x is equal to 1 and y is equal to 1 to take account of the fact that it's being counted twice when we're looking at the two individual outcomes. Now, the key element here is that we know that x and y are independent random variables. So since x and y are independent, we can use the probabilities that we've got in our probability distribution functions to calculate the joint probability, so the probability that x is equal to 1 and y is equal to 1, which is just going to be the product of the probability that x is equal to 1 and the probability that y is equal to 1. So we're going to multiply together those two probabilities. So the probability that x is equal to 1 and y is equal to 1 is 0.05 times 0.05, which is equal to 0.0025. So the probability that x is equal to 1 or y is equal to 1 is equal to the probability that x is equal to 1 plus the probability that y is equal to 1 minus the probability that x is equal to 1 and y is equal to 1, which is 0.05 plus 0.05 minus 0.0025, which is equal to 0.0975. So you might ask yourself, why is this relevant to statistical testing? Well, the key thing is that if the null hypothesis is true, each t-test that we do is like looking at this random variable. The probability of rejecting the null hypothesis, if the null hypothesis is true, is 5%. Just like in this example, where the probability that x was equal to 1 was equal to 0.05. So if we carry out two t-tests, the probability of rejecting on either, if the null hypothesis is true in both cases, is going to be equal to potentially 0.0975. And we'll apply this to t-tests in the next video.